Hi, my name is Gil Gonzalez, and this is my water tower station project. Here's my project plan. Plan for this project is to install a new enclosure for the control panel to have more room to accommodate the customer's request. I also want to have manual mode separated from the auto mode. Manual mode will be controlled as the relay system with pump running at full speed to try and get the level of the upper tank. Auto mode will be controlled by a PLC, and the pump will run with a VFD, both in sync with the help of a PID control. The system will be in place to avoid having auto mode and manual mode on at the same time to avoid backfit from the components. I did a couple reviews during this process. The first one was that I need a J box to have better wire control. Some of the wires in the components were too short, so having a J box would be better. The alternative analysis and summary is that the structure of this project, as it sits, will need some reinforcements to accommodate the new enclosure. The focus will be putting the enclosure in place and the wires that it needs to make sure everything runs smoothly according to the instructions that they have. Next is my project description. It's where I lay out what the project is intended to be. Project will mimic a city water tower. There will be two tanks. The upper tank will represent the tower, and the lower tank will be the city demand. The project will have a manual setting that will be able to control a pump at full speed. In auto mode, the project will run with the PID system, allowing the upper tank to maintain the set limit and allowing the pump to react according to the limit set. There will be a set of instructions to control the pump so it doesn't run dry or the upper tank overflows for both manual and auto mode. Project will also contain an HMI that will control the auto mode. It will have a runtime for the pumps, and it will indicate the set points of the tanks, and it will be able to modify them as needed. HMI will have alarm settings and a historical data trend. The project will contain a set of indicator lights to show the status of the project. Current situation. The project is semi-built as far as structure. It has two tanks. One sits at the bottom and it feeds the pump. From the pump, we have a pressure sensor and a flow meter that connects to the upper tank that contains a pressure sensor valve that gives the reading of how full the tank is. And all this is connected by clear pipe to be able to see the movement of the water. The system is operational. The project sits on a structure made of struts. Proposed improvements. I propose to replace the current enclosure and install a bigger one in its place. I want to make the manual mode and auto mode two separate systems. Manual mode would be a relay system that would be used in case anything goes bad with the HMI, VFD, or PLC, or we have communication problems. To do that, I need more space in the enclosure. I need to add a transformer to be able to get 120 volts, and I use a leg from the three-phase 208. That is the main feed, like they have it right now. Potential risks. Pump running dry is one of the potential risks that this project has, and it will be one of the main focus in the area. The top tank overfilling will be another risk, and the vibration from the pump or the integrity of the structure when the project is running. Here is my IO map. It contains the type, scope, name, description, data type, specifier, and attributes of the input and output. I also have a parts list with information on the power supply, the input and output devices, processing unit, communication, safety devices, and the enclosures. All of these have part numbers, companies, specifications, and a link to the part numbers. This is the bill of material that I used for the project. It contains a picture of the material used as well as the name of the part number, quantity, the price total for each item, as well as the supply link to get the item. And this is the list of materials that I used that were already in the lab. Next, I will talk about my AutoCAD drawing. Here is a view of the back plane of the enclosure, the front of the enclosure, bottom side of the enclosure, as well as the back side of the door. This is the J box, front of it, back plane, and the bottom side of it. Next, we will look at the line diagram. We will start off with the 208 three-phase that is connected directly to the contactors on the manual side, which would be running the pump. On the auto side would be the BFD, and it's being controlled by another set of contactors with the same overload. Next, we have a transformer to step down from 208 to 120. We have a lot of components that are 120, so we needed to add a transformer for that. After that, we have the power supply, and that would accommodate for 24 volts to run everything within that spec of energy. We have the manual side that it's been running with the sensors and the set of lights too. I also have a detailed drawing of the banner safety relay. It just shows how the e-stop push button is wired, as well as the reset on it. And I also have a description of the switch of where everything is being hooked up with the Ethernet, the PLC, BFD, and the computer. And there's also a picture of how the relays are being laid out. Next are my input and output cards. First two are my analog input cards. The next set is my output analog cards. Then we have my discrete inputs. And discrete outputs. This next slide is the owner's manual. We will talk about the content of it. It tells in specific what it does, how to control the program, and everything in between. Purpose of it, how to log in, how to log out. It has specific pictures so the user can understand and have a better view of what to expect. It has the user's access level with their password, username, and what pages they can go into the HMI. Also, it has the operation and system notice, how to power on the project, how the manual mode works, how the auto mode works. It gives a detail of what pages to go to, how to set the set points. The alarms, what to expect with each alarm, how to get rid of it, and what to do when the alarm pops up, and the trend, what it keeps control of, tank 1, tank 2, and the PDI set point. And here's the HMI pages. We have the home page, which is the main page. Now we have the controls page, pump runtime, which keeps tracks of how many hours and minutes the pump is running. Alarm history, keeps how many alarms we've had. The set point page will let you modify the high, the low, and the PID set points. And then we have the print page. Next, we will have a picture of when I was building the back plane of the enclosure. and a picture of where the enclosure and the backplane is all set and wired. Next, we will see how both modes works. We will start with manual mode. We start manual mode by switching the selector switch to hand or manual mode. We check that our pump is running. It should start at full speed, and if you follow the pipe, you will see the water running. That's an indicator that the pump is running. We also have our selector switch to open our valve. We have to do this manually when in manual mode. By opening, you can tell with the clear pipe that the water starts to flow down to the second tank. First sensor would be your low set point. It's set on the bottom tank. And we also have a second sensor on the top tank, which is your height set point. Both of these sensors can be manually moved to the height that you desired. As you can see, the pump keeps up with the demand. We will now try to make the pump go dry to see if the two sensors are working in place. This is being sped up so you can have an idea of when the pump goes out. As you can see, the sensor light goes out once it reaches level and the water stops moving. We will now open it to see if the pump starts again. Water starts to flow down the tank. We'll adjust our valve to the desired. And we will check with our valve to see if the pump is running. As you can see, pump is running. Now to turn off manual mode, you will need to close the valve all the way to avoid the top tank from draining, and turn off the selector switch. And that could be it for manual auto mode. And first step in manual mode would be login. We would log in. You would need to put a username and a password. We will be using Supervisor for this one, so we can have access to all the pages in it. You can find all the users and users' names in the manual. Once you log in, you will need to flip the selector switch to auto. The blue light will indicate that the valve is getting into place. As you can see, it does it by itself manually. After you do that, you will go to the controls page. You can see that it's ready to start with the green light on. We will hit start, and just like that, pump turns green, which means that the pump is running, as well as the valve turns green, giving us an indicator that the water is moving. As you can see, there's 4 gallons per minute going into it, and the top tank is being kept at 6 gallons, and the bottom tank is being kept at 9 gallons. This is thanks to the PID system, which tells the pump to run at a certain speed to keep a certain level that we put at our set points, and it should keep it at the same level all the time. Here we have the pump run time page, which keeps track of all the hours and minutes the pump runs. We all have our reset set point. The set point page is where we can put our high limit and our low limit, and our PDI set point, which is now at 6 gallons, which is where our tanks are being kept. As you can see, gallons per minute is a constant 4 gallons, which keeps it in place for 6 gallons at all times. To stop auto mode, you would hit stop either on the HMI or the control panel. As you can see, the valve would go back to its closed state, and that would stop the auto mode. Here's my PLC program. My main routine has 4 subroutines. The first one is the scales, where all the readings from the sensors are changed to gallons for better understanding. Next is the alarms. Here we have all the conditions that would cause an alarm. Then we have the auto mode program. This routine tells the pump to run or stop and also contains the PID instruction that allows the pump to run at a specific rate according to what you're looking for. And the last routine is the timer that keeps track of the time the pump runs.